Welcome back, focused learners. Today, we've got a seriously fascinating explainer lined up for you. We're digging into a highly experimental piece of applied research published in June 2026. It's an architecture known as XPENV. Now, to be clear, right out of the gate, this is not a commercial product. It's a scientific specification for a true zero-trust messenger architecture built on the Stellar blockchain and Sorbin smart contracts. If you've ever wondered how genuinely secure, high-risk communication actually works at a structural level, well, you're in exactly the right place.
So, here's a question to get us started. Is true digital privacy even possible without a central server? You know, we all just kind of assume that our favorite end-to-end encrypted messaging apps are completely private, right? But the reality is, they almost all rely on central corporate-owned servers to route messages, handle keys, store backups, and crucially, collect metadata. In today's global data economy, big tech surveillance, national security letters, and mass data leaks, they aren't really rare accidents anymore. They're basically the logical consequence of putting millions of messages into one central database. XPENV asks a pretty radical question. What if we just completely eliminate the backend database?
Okay, let's dive into this. We're going to start with the end of the central server, break down XPENV's client-side cryptography, and explore its use of the public ledger. Then, we'll review the penetration testing results, analyze the residual risks, and finally, pinpoint exactly who this architecture is actually for.
Section 1. The end of the central server. The biggest shift here is purely architectural. Traditional messengers hide your content, sure, but their central servers are still doing all the heavy lifting. That means the operator still has the technical power to potentially leak or hand over your data because, well, it passes through their infrastructure. The XPENV architecture operates entirely differently. There is literally no back-end XPENV application server. The client is just a static React and Vite site. All the cryptographic logic runs strictly within your local browser. The publisher simply cannot read, leak, or surrender your data because they quite literally do not possess it. It's a fundamental game changer.
Section 2. XPENV's cryptography.
Now, what's really interesting about this key hierarchy is that instead of a server generating your private inbox key, XPENV derives this key locally on your device. The protocol uses heavy-duty military-grade primitives, specifically Curve 25519 via TweetNAC and AES 256 GCM via the Web Crypto API. Even your backups are secured locally as JSON files wrapped in a dual-layer AES GCM encryption. Because absolutely nothing is stored centrally, your identity is anchored purely to a local mathematical process.
And here's how that math actually works. To generate your secure inbox key, the browser deterministically combines three elements: your public Stellar wallet address, your local profile password, and a strict versioned prefix, which is the exact string XPENV inbox v4. It takes all of that and passes it through a SHA-256 hashing function. Because this derivation happens flawlessly every single time right on your device, keys are generated without ever touching a backend. Basically, if you don't have the password, the key simply does not exist.
Section 3. Public ledger and Sorbin contracts.
So, without a server, where do the messages go? The researchers solved this storage problem by utilizing the Stellar mainnet and its Sorbin smart contracts. Think of this as the locked box on a public square analogy. Messages are stored purely as opaque ciphertext right out there on the public blockchain. Anyone walking through this public square can see that a locked box was dropped off, they can see who dropped it and when. But the box itself? It's completely indestructible and cryptographically locked. Only the intended recipient, using their locally derived key, can actually pop it open.
Now, to prevent bad actors from just flooding this public square with junk, XPENV uses audited on-chain microfees as an economic shield. Sending a message costs about $1.10. But here's the kicker. This isn't some corporate profit mechanism. That fee is strictly divided three ways. First, the Stellar base fee for the infrastructure. Second, a cut to a fixed public wallet starting with GADHO and ending in YCNE for maintaining the static publication. And finally, an economic incentive sent directly to the recipient. Every single cent is auditable on the Stellar Explorer.
Section 4. Penetration testing and QA.
0. That is the exact number of critical failures researchers found during their rigorous June 2026 penetration testing, and this wasn't a light review either. They threw 9 distinct, highly aggressive adversarial suites at this protocol, explicitly trying to break it.
Furthermore, following their remediation period, the Academic Quality Assurance Audit gave the reference build 2.0.0 an impressive 9.0 out of 10 score. Those strict architectural choices, pushing literally everything to the browser edge and the blockchain, clearly paid off when it came to empirical security validation.
And this brilliantly illustrates the scope of that testing. The suites covered 22 variants on the end-to-end encryption protocol, 26 vectors for backup and malware manipulation, 27 complex compound attacks, and 14 explicit cross-site scripting and injection tests. Every single one passed. The client successfully shrugged off metadata attacks, manipulated JSON backups, and web surface exploits. It's seriously robust.
Section 5. Limitations and residual risks.
Now, because this is an objective academic specification, it explicitly declares its own worst-case scenario. To quote the paper directly, simultaneous compromise of the .json plus profile password plus victim's wallet allows reading. This is acknowledged as a universal cryptographic limit, because there's no central server to freeze an account or lock an attacker out. If someone manages to steal all 3 of your authentication factors at the exact same time, the encryption is broken, period.
There's also a fundamental trade-off built right into the core of this architecture. Metadata is public by design. Because it runs on the Stellar ledger, the time a message is sent, the financial value of the fee, and the public wallet addresses involved are permanently visible. XPENV does not guarantee absolute anonymity, and it doesn't try to. You are explicitly trading metadata privacy for the ironclad guarantee that no central server holds your decrypted text.
Section 6. Who is this actually for?
So the crucial point is, who actually uses this? The researchers are very blunt. This is absolutely not for your daily casual group chats. The target audience is journalists, activists, lawyers, and confidential sources. It is built strictly for high-risk communication, where content opacity is non-negotiable, and where relying on a centralized, corporate-owned server is simply too dangerous due to the threat of warrants, NSLs, or mass data breaches.
Which leaves us with this final provocative thought. In a world increasingly defined by big tech surveillance and centralized control, is the trade-off of having your metadata visible on a public ledger worth the absolute mathematical guarantee that no central server can ever read your messages? It's a pretty massive paradigm shift in how we think about digital trust. Well, that wraps up our explainer on the XPENV architecture. Thanks so much for learning with us today, and we'll catch you on the next one.